So uh, classically, this is what how we visualize electrons, right? Spinning about its own axis, and this orbital motion that you can see. The yellow color thing is the nucleus, and the blue color is that spinning sphere that you see is the electron. Mind you, this is the classical picture. Whenever we say, I'm not saying this picture is 100% true. This is only a classical viewpoint, but it helps to build up initial view of the things, and then we modify it that and tell you that no, in quantum mechanics the treatment is slightly different. Okay, you have never heard of an electron having certain diameter, certain thing, nothing, nobody knows it. तो पार्टिकल जैसा तो कभी किसी ने रियलाइज किया ही नहीं है, मतलब एक्सपेरिमेंटली. सो दैट इज. और जब भी वो करने जाते हैं स्पिन का आपको प्रॉब्लम आता है जो हमने किया. सो इट हैज टू एंगुलर ऑर्बिटल एंड स्पिन. मोमेंटा लिखते हैं प्लूरल होगा, मोमेंटम लिखेंगे सिंगुलर. अगर एक मोमेंटम की बात करेंगे मोमेंटम, कई सारे मोमेंटम तो मोमेंटा. इसलिए ध्यान रखिएगा जब भी हम अंग्रेजी लिखते हैं पढ़ते हैं तो शब्दों का बैक्टीरियम बैक्टीरिया उसी तरह से है, मोमेंटम मोमेंटा. So that analogy helps you understand why we are using these words. Somewhere momentum, spectrum, spectra. हम कहते हैं ना स्पेक्ट्रम है, स्पेक्ट्रम इज सिंगुलर, स्पेक्ट्रा इज प्लूरल. देखिए बच्चों को कंफ्यूजन रहता है, इंटरव्यू में कई बार पूछा जाता है ब्लैंक. सो यू हैव टू बी अवेयर ऑफ दैट. बहुत सिंपल सी चीज, स्पेक्ट्रम और स्पेक्ट्रा में क्या अंतर है, बस नहीं बोल पाते हैं. तो ये सब बहुत सिंपल चीज है, ये जस्ट अंग्रेजी के वर्ड्स हैं, उसका सिंगुलर प्लूरल है. तो जैसे दो इलेक्ट्रॉन है इन in P2 configuration we have two electrons, each one has L is equal to 1. So when you are in p orbital, L is 1 for all, both the electrons, right? The values of ml can change, can be different or be the same. So we have three such options. How? So when you are considering the orbital angular momentum of electron number 1, electron number 2, electron 1, electron 2. This is what how I started yesterday and told you ये 2 वाला है. And then both the angular, there is vector addition being done. So इसका भी वो हो गया अंडर रूट जो आप जानते हैं L इंटू एल प्लस 1 H क्रॉस, ये भी हो गया L इंटू एल प्लस 1 H क्रॉस. सो ये दोनों ऐड होके नेट आपको एंगुलर रिजल्टेंट एंगुलर मोमेंटम मिलेगा जो होगा. सो दैट्स हाउ वी राइट इट in a. So another option is that the two angular momenta are oriented in this manner. So एक है perfect alignment of the two angular momenta. The other one is like they are making angle like this. So in this case ये जो length है, this is same as this one. Can you see vector addition है? You can see if they are in this way. So the overall the summation L turns out to be 1 if they are. तो ये समझ रहे हैं. देखिए कई बार आप क्या करते हैं कि आप लिख लेते हैं सब टर्म सिंबल का रटा हुआ फॉर्मूला है वो सब करते जाते हैं, लेकिन उसका जो रियल मीनिंग है यू डू नॉट अंडरस्टैंड द रियल मीनिंग, द फिजिकल सिग्निफिकेंस ऑफ दैट इज समहाउ पीपल मिस आउट. They solve bigger problems but they do not know what it actually means. So this is what it means when you say L is equal to capital L is 1. So it is summation of two angular momenta which add up to 1, right? And both of them are having L is equal to 1. That is same angular momentum as the in the previous case. The vector, the arrow length of the arrow would be same, and resultant would be different. So how do we bring out the same thing? So this is how we L into L plus 1. So sum of these two will give you the net angular momentum, which is given by this capital L, and this is the new quantum number we say, and corresponding to that we have the state that we define P. So if L is equal to 1, जैसे आप L is equal to 1 के लिए small l के लिए करते थे d orbital p orbital, so we say capital D, capital P now. That's how we will write. And the third possibility is this one, that both of them are just opposite to each other. The two vectors are opposite to, in this case L is capital L, the sum of the two vectors is 0, and this is, so you remember, just like you had small l changes like 0 1 2, and you were assigning small letters S P D in small letters, you were talking about this. Now you have L, capital L, 0 1 and 2, and so you are using the same but capital. For 1 you are writing P, capital P. For this you are writing D. So these are all in capital. So it runs in parallel to what you have already learned for individual one electron. हाइड्रोजन एटम के लिए जो आपने सीखा एक इलेक्ट्रॉन के लिए, अब मल्टीपल इलेक्ट्रॉन्स हैं और सबका एंगुलर मोमेंटम ऐड हो रहा है. They, so this is another kind of interaction that happens, and later on I will tell you how it is basically a magnetic interaction that happens, because the two electrons are behaving as tiny magnets. Each of their magnetic moment is due to the angular momentum, spin angular momentum, orbital angular momentum. So so you can say that this kind of interaction is through space. It happens through space interaction. कोई touch नहीं कर रहा है एक दूसरे को. It is just they are interacting in space. It is a through space interaction without any contact, and that's how you have the addition vector. The two vectors add up. Okay, it is a vector addition, so three-dimensional orientation, that is important, and that's what we have seen. Okay, so if there is, so let's visualize two electrons. So it is, first let us try to understand everything based on the two electron system. So if you have closed shell, complete shell, and then outer valence shell you have two electrons outside closed shell, then the closed shell, remember the closed shell does not contribute to angular momentum. पूरा जो overall है cancel out हो जाता है. So any closed shell of electrons gives zero angular momentum. Only those which are the shell which is not yet filled completely, the outermost shell which is incomplete, that one, only that one contributes to net angular momentum for the atom that we can talk about. So so the orbital angular momentum quantum numbers of the two electrons are L1 and L2. So we number the two electron number 1, electron number 2, and then we can electronic configuration we can write for P2 के लिए लिख रहे हैं L1 L2 both is equal to 1. And then what is the possibility? So the pictures that you have seen here, it sums up the, there are only three possibilities for vector addition for these three three possibilities for two electrons, and that total orbital angular momentum is given by a new set of quantum number capital L, right? And how many values that, what values that capital L could be is given by what we know as Clesp-Gordon series. So this is how you have to do it. The capital L, so two electrons, L1 plus L2, then L1 plus L2 minus 1, and so on. It will go on till you reach L1 minus L2. So what you have to do, so here in this, if P2 electron 1, this is L is equal to 1, L1 1, electron number 2, we say it has L2 is 1, दोनों का 1 है, L वैल्यू दोनों के लिए 1 है, तो यहाँ पे L1 प्लस L2 क्या होगा, 1 प्लस 1, यहाँ पे क्या होगा 1 minus 1, so this is, so it will turn out to be 2 and the last one will be 0. अब इसके बीच में ही कुछ होगा, so you fix the two ends. तरीका क्या है, what is Clebsch-Gordon series, you fix the two ends, add all the L values together, so for two electrons L1 plus L2, and then you fix the other side L1 minus L2. So these are the two extreme values of L, the capital L that we can have, and in between you fill out by counting 4, subtracting -1, and so 2, 1 and 0, 3 possible values, and we have just seen through pictures 2, 1 and 0, 2, 1 and 0. So this is how the pictorial view, and this is what the Clebsch-Gordon series tells you how you have to add it. Okay, so this Clebsch-Gordon series is important. It tells you what are the possibilities, and the pictorial view I have just told you. So it tells you what, it gives you magnitude, relative orientation, that it also hints to you. So again, how will you give the magnitude? How can you calculate the magnitude for two electrons interacting with each other? L into L plus 1. Now this L is the capital L, right? H cross. And how many orientations are possible? Again, it will be given by capital 2L plus 1 values. And what will be the Z component? What will be the magnet? How will you calculate the magnetic moment? That is through ML. Just like you have small L and the ML values were there, that tells you about the Z component. Similarly here also, एक बार जब आपने कैलकुलेट कर लिया टोटल ऑर्बिटल एंगुलर मोमेंटम, कैपिटल L वाला निकल गया, then the same thing. So what you understand now is that total angular momentum orbital angle, so we are only summing up here the orbital angle, total orbital angular momentum. It is given by quantum number L, which is sum of, can be L1 plus L2, 1 plus 1 2, ये हुआ. अगर 1 plus 1 2 हो गया तो accordingly you will draw, and so when this is the value, magnitude of angular momentum will be under root 2 ये वाला होगा, right? And possible ml values will be range from +2, +1, 0, -1, -2. So again it will be in the same fashion that you will draw an like in a three-dimensional space. If this is your z-axis, this is x, y, so something like this it will have. So this one will have the z component, and this is given by ml h cross. The z component ml h cross, and this is your under root capital L, right? So you understand this is your thing. So ml का सिग्निफिकेंस समझ रहे हैं, वो आपको z कंपोनेंट ऑफ टोटल ऑर्बिटल एंगुलर मोमेंटम बता रहा है, ठीक है। अगेन जो क्वेश्चन मैंने आपको दिया था अभी टेस्ट में, वो अगर मैं फिर से रिपीट कर दूं और इस बार कहूं कि टोटल एंगुलर ऑर्बिटल एंगुलर मोमेंटम बताओ, उसका z कंपोनेंट कितना है, कितने एंगल पे होगा, तो स्केल यू कैन ड्रॉ दी स्केल वेक्टर डायग्राम, राइट? So you understand now when you have making this plus 2, so you can, so if ml is, so this is what it means when we are talking about the same vector. Now it will have same length, but if you tilt it a bit, it will, you will have reduced value of z component, this value, oh sorry, I'm so sorry. So z component, this is my ml h cross. So here the so if I am drawing the same length of the vector, so I will keep the length same because it's 2. Here in this picture L is 2, but ml is plus 2. In this picture L is equal to 2, but ml is plus 1, so it will have reduced value. So ये जितना था उससे काफ़ी कम आपको यहाँ पे दिखेगा, so like that. And when it is 0, the same vector is now having no z component, and then when it is 0, this vector is pointing in this direction, right? So z component is 0, then ml is 0, and this one is same length L into L plus 1. This should be your length. Length will be remain same. Length of the vector, total orbital angular momentum, is still the same. Only orientation in the 3-dimensional space is changing. So do you understand what it means now? जहाँ भी angular momentum आएगा, it is a vector. It has magnitude. It has direction. And to define the direction, you have ml values, which once you fix the z component, you are the overall, the total angular momentum, it has now different directions under the different values of ml, right? So this is what it means when you are putting it -2, then this vector is pointing in the, if it is L is equal to 2, and if you move it like this, if I place it like this in this manner, then it has a component along this, so L then would be -2, and then we will be showing it over here. So this is what it means, -2 में पूरा डायरेक्शन ऑपोजिट हो गया, z कंपोनेंट चेंज हो गया. So this is your z component, how it changes. So you understand, इस तरह से आपको देखना है. और एक चीज आप देखिएगा, for given value of L you can have several values of ml. अब इसमें L का वैल्यू कॉम्बिनेशन से कितना आया, सो ये जस्ट एक ही सेट आया है. इसके बाद L1 प्लस L2 का कॉम्बिनेशन एक ऐसा भी है जो 1 देगा, L1 प्लस For the second combination, L is L1 plus L2 minus 1 is equal to 1. So in that case also you will have ml plus 1 will be there, but that the length of the arrow will reduce. कैपिटल L का वैल्यू कम हो गया ना. अब अगर हम ड्रॉ करेंगे तो लेंथ ऑफ द एरो विल रिड्यूस, द एंगल्स विल ऑल्सो चेंज. थोड़ा सा प्रैक्टिस करके सोचिएगा. ml plus 1 will come in different. If L is equal to 1, then also you will have ml plus 1. ml plus 1 is also there when you have capital L is 1. What is the difference? What is the difference between the two? In one case, the length of the arrow, total orbital angular momentum, is large. In the other case, when capital L is 1, the length of the arrow will be smaller. And what about the angle? The z component will be different. The angles? Calculate करके देखिए. So calculate these angles. You can do that. Okay. So this is what we are going to follow. The mnemonics. The how do we represent them is that just I have already explained to you. So we use the capital letters SPDF, and remember, as I told you, closed shell has zero orbital angular momentum because it is a vector sum of all the angular momentum, right? तो जब आप एक क्लोज शेल में सारा कॉम्बिनेशन लेंगे तो जीरो हो जाएगा. सोच के देखिए. +1 0 -1 p सब शेल खत्म. अगर if it is completely filled, the net angular momentum will be 0, net orbital. So that is true for any subshell. And then if for subshell, if it turns out to be like that, overall in any case, any complete shell will have that zero orbital angular momentum. So practically, whenever you are asked such questions to work out the term symbols, you only refer to the unfilled shell. Only worry about the unfilled shell, look at the number of electrons, and that's how we do it. So suppose you have sodium. If you are asked to work out the details, find the possible values of total orbital angular momentum, how do you start? In case of sodium, it is a completely filled shell of neon and then 3s1, right? So L1 plus L2, there is only one electron, so there is only one L value, which is 0, and so it is S term. L is 0, and so capital L is also 0. So this gives you S, capital S. So they differ in energy due to Coulombic interaction that we have considered. Uh, so there are two things that we can think of. L is equal to 2, the D state. There are two ways of to achieve D state. How can you achieve L is equal to 2? And there are also possibility of L is 0. Capital. So in two electron system, you can have this one. There is also a possibility when you have 2p1 3p1 configuration. Both electrons so think about this one, 2p1 and 3p1. One electron is in third shell, another one is the second shell. So both can move around the nucleus in the same direction. So they are always away from, so like this. If this is something like this circulating around in the same direction, and you will have the then the two electron 1 2. So it is L is equal to 1, L is equal to 1, and so capital L is 1 plus 1 2, right? In such case, so it can be like this moving. But when you have to be like capital L is 0, in that case they must be, oops, sorry, but if you are talking about another case, think about the second case. This is 0, that means L1 minus L2 1 minus 1 is 0. That so they are an opposite to the two vectors must be opposed to each other, so that which means two angular मोमेंटम, अच्छा मोमेंटम ही लिखते हैं अभी, वेक्टर्स of to each other. So in that case, so you have to, how do you imagine that kind of situation, that capital S is 0, so the two momentum will cancel out each other if the two electrons are orbiting each the nucleus in a opposite manner, like this. So in such a case, there's chance that the two, the S is equal to 0 term, they need to be circulating in opposite direction to each other. Only then they will be having net zero angular momentum, zero orbital angular momentum. So this state means that you have zero orbital angular momentum. The two electrons taken together will have zero orbital angular momentum, right? तो ये zero कब होगा? So your immediate interpretation is you imagine the two electrons to be moving in opposite direction with the same L value, but if they are moving in opposite direction, then the two vectors will cancel out, and that's how we get an L, capital L0 state, right? So for that to happen, but if they are moving in opposite directions like this, then the chances of meeting, कि एक जगह पे मीट करेंगे, बहुत ही क्लोज आ जाएंगे, वो चांस ज़्यादा होगा, और इसलिए उनके बीच में रिपल्शन भी ज़्यादा होगा, और ऐसे केस में एस वाला जो स्टेट है that will be of higher energy. So in the latter case, when the two momenta cancel out, they are moving in opposite direction, that's what we imagine, and in such case the two electrons, when they are moving in opposite direction, the two electrons may meet each other. जब मतलब एक सर्कल में दोनों घूम रहे हैं तो आपस में एक दूसरे के आमने सामने आ सकते हैं ना. So that is the situation. They are moving on, suppose they are moving in one circle opposite, in opposite direction, the chances are they will come head on, face to face, and that will be huge repulsion will be there in such case, and so energy will be high, right? So that is, so so that is what happening. So in such cases the S term will have higher energy. So that is the reason we have replaced this term S term. So that's why the S term is of higher energy. Right, so that's one of the explanations that we fundamental, it is for your fundamental understanding. कई बार आप सब सी मतलब ऐसे स्टेट निकाल लेते हैं लेकिन आपको पता ही नहीं होता कि वो ऑर्डरिंग ऐसा क्यों है. Why D is lower in energy, S is higher in energy. So S term will lie higher in energy than D term. Okay, repulsion, when if the chances of them meeting each other is more, the energy will be increased due to repulsion, and therefore S term will lie higher energy. This is the point to be noted. You don't get everywhere written in books everything, right? So थोड़ा ध्यान से सोचिएगा. ये possibility है quantum, and this is our classical visualization, classical picture that emerges to our mind. And quantum mechanical analysis also supports this interpretation. जो interpretation ये simple तरीके से हम समझ पा रहे हैं, visualize कर पा रहे हैं जिस picture के through, the same thing, even if one some hardcore analysis is done based on quantum mechanics, the thing is uh, uh, same thing comes out to be true. So that's what we are talking about. Low value of L, some electrons in the opposite direction. So this is what we have to think, that whenever you are trying to cancel out the L with another L, one angular momentum cancelling the other angular orbital angular momentum, they must be moving in opposite direction. So this is moving in this direction, and whenever this is happening, they are likely to meet each other at some point, and that will have higher energy. So you will always find such things happening, that S state, uh, whenever you have S state is higher in energy. Okay, like this. Why the high value of L is, this has lower energy. So ordering you can see here, if high value of L, and so L is 1, L is 2, L is 3, L is 1, L is 2. High value of L is having lower energy. So that is what we know as orbit-orbit interaction. So it is angular momentum or angular momentum arising due to the orbital motion. So we can call it orbit-orbit interaction also. Okay. So if you are asked this question, why is higher angular momentum state lower in energy? Higher angular momentum but lower energy. That's the reason that we have just discussed. Okay. Whenever they try to cancel out, you can imagine electrons moving. Apply right hand thumb rule. You tend to be curl the when you try to curl your fingers. That motion of the two electrons is opposite to each other. They are moving in different direction, opposite direction, and in such case, they are likely to meet each other. They will come face to face. The repulsion will increase, and that's why they will have higher energy. ठीक है? Another way to look at it as, if electrons are closer together, there will be more shielding and the electron energy will be high. Let's, okay, so let's try to answer a few things before we close the class. Find the terms that arise from D2 and P3. How do you proceed? D2 is very simple. You have only 2 electrons, so follow the make a crisp Gordon series, finding the minimum value of L and maximum. दोनों end को पहले पहचान लीजिए, L1 plus L2, L1 minus L2. So that's how you start with. So electron number 1, electron number 2, this one is having L2, this one is also having L2, right? So, or you say that this is for electron number 1, L1, you put it 2, L1 plus L2. So, when you're trying to make this Gordon series, it gives you L, different values of L that are possible, L1 plus L2, one end, and the other end you have L1 minus L2. So what are the possibilities? 2 plus 2, here 2 minus 2. So this one is 4, this one is 0, 4. So and rest you go on reducing by 1, 4, 3, 2, 1, and then 0. These are the L values. For each value of L, you will have ml from plus 4, plus 3, and so on up to minus 3. So on. So you will have minus 3. I'm not able to do that. And so on, minus 4 up to minus 4. Sorry, I'm not able to write. So that here you will have ml plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. For this one, ml would be plus 2, plus 1, 0, minus 1, minus 2. For this particular thing, ml will be. So how do you, so you can have these many values of the total angular momentum, 4, 3, 2, 1, 0, and for corresponding to each one of them you can have different orientations of the vector. The z component will be different, and the z component is given by the m with subscript L, right? So that's how you have this thing. So it is easy to understand what is the significance of each of them. So this is how you play it out. So we make a list Gordon series, and the way I have told you, you start with 2 and it's 0, 4, 3, 2, 1, 0, and the states go it alphabetically: S, P, D, F, S, P, D, F, and this one is G, if you name it like this. So capital S, capital. So that's what we have here. In the second case, what will you do? You have 3 electrons, P3. So take 2 at a time and then add the third one. That will be easy. So you add first one to, so you have combinations. So take in P3, take 2 electrons first at a time. So you have, and define the L dash, L prime. Okay. So that will be from 2 1 0. Now take this as L prime 2. So for each value of this L prime you will have combinations that now you couple L3, the third one, the third electron has L3 is equal to 1, and now you couple with this thing L prime 2. So now it will be 2 plus 1, 1 plus 1, 0 plus 1. So that's how. So when you are doing with L3 you are adding 3 to 1. Then couple L3 with L prime 1, and then you also do the same with 0. So you are coupling with all the 3 to get the value L values 3 to 1 2 1 0 L is equal to 1. Okay. So what you have done, just so you are having, now again we will write a Clese-Gordon series for this particular one, and how we get this. So L3 is equal to 1. That's what we are writing. So now what we are doing, L will be equal to L prime plus L3 up to L prime, like this. So you will have to add and then write like this. So again you will work out the details in the same fashion, and you will have 2 plus 1 3, 1 plus 1, and 0 plus 1. So we have 3 values of L prime, and so 3 values corresponding to each one of them, and that's how you get 2 plus 1. L will be also be equal to, when L prime is 1, 1 plus 1, so 2, and you are taking this one, L prime is 0 plus 1, so I have 3 values of, so 3 2 1. So 3 2 1 is the first set of values. So you have the L, you know, first set of L values you get, then you take the other one, other L prime value, uh, in a similar fashion. So you start with L prime 1 and you get this 3. Okay, so we can calculate this, and you will have total values of L, capital L, will be this 3 2 1 2 1 0 1 L is equal to 1. So these are the overall result. L is equal to 3 2 2 1 1 1 0 1 F 2 D 3 P and 1 S. So this is how we make it through the Clese-Gordon series. So remember what we have done? First 2 electrons, then couple each one of them L3 2 1. So 2 plus 1 2 minus 1. That's the series. So मतलब हम क्या कर रहे हैं, एक बार L prime बना लिया, we are taking this one, L is equal to L prime, sorry, for L prime plus L3. So we are taking 2 plus, so L prime, uh, and then you go on extending it till L prime plus minus L3. जैसे हमने पहले किया था वही करना है. इसमें और कुछ नहीं है, बहुत इजी है. सो 2 plus 1 and here 2 minus 1. That's what we have done. So 3, 2 and this one is 1. 3 2 1 आया. फिर दूसरी बार हमने क्या किया, दूसरा वाला L लिया. This is 1 and this one is 1. So 1 plus 1 is 2 and the other end 1 minus 1, it is 0. So 2 1 0. So that's what we had, 2 1 0. फिर हमने तीसरी बार क्या किया, we are taking the third one. So you always go on changing. You have three values, now take 0. L prime is 0. You take, so when you have 0 plus 1, so you can have only one value, uh, only one in the last case, when it is 0. So that's how you arrive at these 1f state, 2d state. So इस तरह से आपके पास टोटल आपका समझ गए. तो 3 इलेक्ट्रॉन होने पे कैसे आपने किया. So this is the very fundamental way of doing, arriving at the what terms, how many numbers, how many of one particular term will be there, 2d and 3p. How do we realize? So this is, you can see 3p, 2d, 1s, 1f, right? So this is how we are arriving at this. Very easy to do. And this is how we can sum it up पिक्टोरियली. पिक्चर के थ्रू देखिए कैसे इसको समझ सकते हैं. देर so this is, so again this is what we mean when 2 plus 1, we are doing it like this, 1 plus 1, so capital L plus L, L1. So okay, so we'll continue this discussion in the next class, and I'll discuss this a bit more. So this is how we understand how do you arrive at these many states, F state, D state, P state, and the how many degenerate states you are getting into. Okay, continue this. We'll continue in next class.